Hello everyone, welcome back to my channel. In today's video, we are going to learn about logistic regression in machine learning. So without further ado, let's get started. So what is logistic regression? Logistic regression is a supervised machine learning algorithm that helps us to predict categorical outcomes such as yes or no. Logistic regression is not used for regression problems. Instead, it's used for classification problems. Example of logistic regression are it helps us to predict categories such as whether an email is a spam or not, whether loan is approved or not, whether a student passes or fails. Therefore, logistic regression has output probabilities between 0 and 1 that are converted to either yes or no or 0 or 1. Equation. The logistic regression model uses the logistic function to predict the probability. First, let's see the linear equation. Linear equation is equals to z equals to b0 plus b1x, where x is the input variable, b0 is the intercept, and b1 is the coefficient. So, to squeeze this z into a probability between 0 and 1, we use sigmoid function. Logistic regression equation. So this is the formula of the sigmoid function, where p is the probability of dependent variable, b0 is the intercept, b1 is the coefficients, e is the base of the natural logarithm, x is the independent variable. So if we plot this logistic regression equation, we will get an S curve. This is called sigmoid curve. You can see logistic regression function returns only values between 0 and 1 for the dependent variable. We divide into two categories, class 1 and class 2. 0.5 is the point to divide between two classes. Therefore, if p is greater than 0.5, then we predict it's class 1 or pass or S. Similarly, if p is less than 0.5, then we predict it's class 2, which means fail or no. Let's see an example of logistic regression. Suppose we decide the result of exam based on study hours. So here we have our data. Here input is hours studied and output is result, that is pass 1 or fail 0. As we see, the probability of passing is near 1 if students study for longer hours, whereas the probability of passing is near 0 if the student study for short hours. And around 3.5 or 4 hours, the probability crosses 0.5, and that is called decision boundary. Now let's practice logistic regression in Python code. Let's see how we can implement logistic regression in Python. First, let's import some libraries. So, has importing libraries. So import numpy as np. So numpy is used to create data arrays and it is for numerical operation. Another is import matplotlib dot pyplot as plt. So this is to visualize the data from sklearn dot linear model import logistic regression. So this line will import logistic regression. Now let's create a data set. Therefore has data set and x equals to np.array, and then I will give 1, 2, 3, 4 and then 5, and dot reshape -1, 1 and then close the parenthesis. So here x is the hours study, which is our input, and this is independent variable, and another is y equals to np.array, and I will give 0, 0, 0, 0, 0, 1, 1, 1, and then this. So here y is where we store the results based on the study hours. Next is to create and train the model. As creating and training the model. Mode equals to logistic regression and then so this line will create logistic regression model object. Then another is mode dot fit and then x comma y. The mode dot fit is where training happens, and after training the model knows more study hours has high chance of passing. Next step is to predict. Therefore, as predicting, let's say for 4 hours, so probability equals mode dot predict underscore proba and then I will give 4. So this will get the probability for 4 hours. Another is to print like probability of passing for 4 hours of study and then I will give probability 0 and then 1, close this parenthesis. So this probability 0 and 1, it gives the probability of class 1, that is pass. So this line will predict our result. Next step is visualization. So visualization plt dot scatter and then x comma y comma and we'll give the color equals to blue and comma will label and let's say actual data and then parenthesis. So this line plots the actual points and it is denoted by blue dots. Another is plt dot plot and then x comma mode dot predict and underscore proba and x comma 1 okay comma color equals to red comma label equals to logistic curve. So this plot will draw the regression line predicted by the model and it is denoted by the red line. Next is plot dot x label and then study hours. So this is the representation for x-axis. Next is plot dot y label and then pass probability. So this is to denote y-axis. And let's do plot dot legend and plot dot show. So this line will display the plot. Now let's run this code. Error here, plot mode dot fit xy. Okay, there is error. Let's fix this. Mode dot fit xy. I think this is right. Ah, I got this. This is 6. let's run. Okay, next is, okay, for this error I think I forgot to give parenthesis. Okay, let's run and see. I'm sorry. So let's fix this. Let me do like this. Now let's run. So this is our result. The probability of passing for 4 hours of study is 0.63, that is equal to like 63%. So this is the example of logistic regression. Yeah, now let's move to the another chapter. Types of logistic regression. There are 3 main types of logistic regression. One is binary logistic regression, multinomial logistic regression, ordinal logistic regression. Now let's see each of them. Binary logistic regression. This is used when the dependent variable has only 2 possible outcomes, and this is the common type of logistic regression. The examples are, we can categorize results as spam versus not spam. Similarly, pass versus fail, or yes versus no. Multinomial logistic regression. This is used when the dependent variable has more than 2 categories, unordered. The examples are the predicting the types of vegetable like broccoli, beans, eggplant, and so on. And another is predicting customers' preferred payment method, either cash or card or online. Ordinal logistic regression. This is used when the dependent variable has 3 or more categories with order. It takes order of categories into account. The examples are customer satisfaction. We can categorize as poor, average, good, or excellent. Similarly, we can categorize hotels ratings as 1 star, 2 stars, 3 stars, 4 stars, or 5 stars. Advantages. The advantages of logistic regression are, it's good for binary classification, it's simple and easy to understand, it is fast and efficient, it provides probabilities, not just class labels. Disadvantages. The disadvantages of logistic regression are, it's not good for very complex data. Similarly, it is difficult with multi-class problems, and it only works well when the relationship is roughly linear in the log odds. Applications. Logistic regression is widely used in medical field, banking, marketing, email filtering, fraud detection, weather forecast, remote sensing, insurance company, and so on. Okay, that's all for logistic regression. So today we have learned that logistic regression is used for classification, and it uses sigmoid function to output probabilities, and it is very simple and widely used in real world applications. If you found this video helpful, please don't forget to subscribe my channel. I will come with a new topic in next episode. I hope you all are enjoying this machine learning series. See you in the next video.